This video covers section 10.4, graphing quadratic functions using transformations. When graphing quadratic functions, we must always keep the graph of y equals x squared in mind. This one serves as the basis for the shape for all graphs of quadratic functions. And the properties of this graph rely on knowing the squares of the numbers. Y is equal to x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Lastly, 4 squared is 16. So the y equals x squared goes through 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. So it's kind of thought of as going over 1 up 1, over 2 up 4, over 3 up 9, and over 4 up 16. On the left side of it, when we square those numbers, the square of a negative number is positive. We get the same numbers on the other side. So it is the mirror image on the other side. Negative 1, 1, negative 2, 4, negative 3, 9, and negative 4, 16. So what you see on one side, you see the other side. So when graphing any one of these, we're always looking for this beginning point, and then you have the same graph on both sides. The graph of this is what we call a parabola. And now we're going to do in objective 1, graph quadratic functions of the form f of x equals x squared plus k. We're going to keep in reference the graph of y equals x squared, 1, 1, 2, 4, 3, 9, and the negatives have the same y values. And we think of f of x now as being that same graph, but with 4 subtracted from all of the y values. G of x passes through 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. Whereas f of x passes through those same numbers, but 4 taken away from them. So if it was 0, 0 minus 4 is negative 4. If it was 1, 1 minus 4 is negative 3. If it was 2, 4 minus 4 would be 0. 3 squared would be 9, minus 4 would be 5. So it's these numbers subtracted 4. 1 squared is 1 minus 4 is negative 3. 4 minus 4 is 0, and 9 minus 4 is 5. So f of x goes through 0, negative 4, 1, negative 3, negative 1, negative 3, 2, 0, negative 2, 0, 3, 5, and negative 3, 5. So it looks exactly the same as the graph of x squared, but we say that we've shifted the graph of g of x equals x squared down 4. In example 2, we have the points of g of x equals x squared and now f of x, we're adding 2 to all those y values. So it's going to be 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, 9 plus 2 is 11, 1 plus 2 is 3, 4 plus 2 is 6, 9 plus 2 is 11. So we have the graph of g of x and now f of x is going to be that same graph, but we're adding 2 to every one of our y values. So now we're starting off at 0, 2, 1, 3, 1, 3, 2, 6, and 3, 11. Negative 1, 3, negative 2, 6, and negative 3, 11. So we see that this graph has been obtained by shifting the graph of g of x equals x squared up 2. So it makes sense. We've got the minus 4, we shifted down 4. We've got the plus 2, we shifted up 2. So we say that in general, to graph a function of the form f of x equals x squared plus k, or f of x equals x squared minus k, we shift the graph up k units if k is positive, and we shift the graph down k units when k has a minus in front of it. And this concludes the video for section 10.4, graphing quadratic functions using transformations. Objective 1, graph quadratic functions of the form f of x equals x squared plus k.